I can do it. Yeah. Hi everyone. We're going to kick off now. So feel free to grab food and bread, and all that. Right, welcome to event number 2 of our relaunched Auckland Microsoft Azure Meetup. Thanks everyone for coming. Get some housekeeping. If you need a toilet, straight out down that hallway, straight out the door. It's me on light helping the way. Yeah, thanks again for coming. I'm James. I'm the CTO here at Parallel. Who are sponsoring the event very kindly. So put on some food and drinks for everyone. This is Brent. Yeah, so again, welcome. We've got Zoran. Well, he can introduce himself when he starts. But I think that's probably about it. Yeah, just cut yourself to food as we go. And I've got, this is being streamed and recorded, so there are some people online. Hello. And yeah, so if you do want the video afterwards for any reference, then we'll post that back on the Meetup. Anything else? Cool. Take it away.
Hi all. First of all, say thank you to Frank Jensen, Paolo, and Microsoft support. And I'm really thankful for calling me to the session for Auckland Microsoft Azure Meetup group. And we're gonna say a few words about me. I'm the principal data architect at C7. I'm MCP as well. MCP. I'm doing blogging, doing speaking. I have a Meetup group as well, Azure SQL group. And yeah, let's not waste time there anymore. So we're gonna talk about the platform as a service and what kind of deployment options we have there. And it's a kind of hot topic. Lots of people just looking at still in New Zealand to move to Azure. And this is, yeah, this is the best option you can choose. So this is going to be the agenda for today. We're not going to go across too deep to all those sections because you need like a few hours just to cover that. We're going to talk about some limitations of each deployment model you can choose, but again, not going to go too deep. We're going to talk mostly about the HA and architecture in the back and what you're getting once you move to platform as a service Azure. So first of all, lots of people struggle to understand what Microsoft Azure is offering with the platform as a service. So you need to understand and separate 4 different layers when you're choosing your target platform. If you're going to use MI or use Azure SQL database, whatever you choose, you need to understand those 4 layers you have. So you have deployment models, which you're going to choose, which is going to be your target version, purchasing models and service tiers behind the purchasing models, and you have availability models on that. Every single price, every single service tier is actually leveraging one of the availability models. Those are deployment options. You have Azure SQL. So you have on the left side, you have a managed instance. On the right side, you have a database. Behind those 4 models, you have different service tiers. So we probably guys heard about the hyperscale. This is just a service tier of Azure SQL database. And I'm going to scratch this surface later on in one of the slides. So first, we should say some kind of like reasons why you should or shouldn't go to the single instance or instance pool. So if anybody of you ever deployed a managed instance, single instance or instance pool, you're going to see the difference. It's a big difference directly from a portal from Azure. You need to use PowerShell to deploy instance pool to manage that. And the reason is there because some customers would like to use maybe more in the one virtual cluster, more different instances instead of one big one. And you can go as low as 2 cores per instance with the instance pool. But I think MI is more in use as an option. And you can use the 2 purchasing models that MI. So that's V4. Actually, just one purchasing model, that's V4, but 2 service tiers. So you can use the business critical and you can use the general. Nothing else is available. You can't use VQ. You see what VQ is later on. So one of those 2. And there is a quite big difference, but architecture is quite the same with the Azure SQL database and MI in terms of availability in the back. So mostly everything relies just on service tiers and availability models in the back, what those service tiers leverage. Instance pool, we already said, single database and elastic pool, so it's coming from the same family. You have hyperscale option now, service tier, that's like Microsoft worked the last 5 years, but let's say you have 2 years of available, and it's really, really cool, my favorite one, say. So I think that Microsoft will invest in that more than anything else. And the second one will be Azure SQL, but that's just my. The biggest issues we have. Okay. So what I found moving other customers to the cloud, to the Azure PaaS, I found that the biggest issue they may have is the size of the database, because almost all of those, they have 4 terabyte limits, except MI, general purpose. It has 8, it's recently has 16, but 8 additional 8 isn't preview currently. So it's understandable why those business critical and premium have that. You can see later on through the architecture of those. Why is that? So you have a service which is general purpose available just, and you fully manage all of those managed. I'm going to show later what does that mean. And you have elastic pool option. It's a pretty much deploying elastic pool, adding in database. You can share those views or resource per database. It's really useful. We had I had one situation that they have a customer, let's say, customer from USA and customer from New Zealand or Australia. They actually pay those details. We go just to scan. They like different workloads at different times. So one location, so one service here for both. And if you have predictive workload, you can use that. So those are talked about deployment models or options. So there is this is the purchasing model and service tiers. Later on, we have a full graph and like one kind of nice to show you how that looks like in real life over there. So this is the BTU purchasing model and BTU purchasing model, 2 purchasing available. Behind those purchasing model, you have a service tier. Every tier there leveraging one of the availability models in that. So you can see there that BTU is for Azure SQL and Elastic Pool. We don't have that. We don't have that. They're just using. And those service tier there, you can see that's basic, standard, and premium. Premium and it's critical from a big model, they leveraging the premium. So they're leveraging the HA architecture. I'm going to show you that later on the slide. Everything else except the hyperscale, everything is leveraging the standard. So it's still ability. You need to understand once you choose the Azure SQL platform service, inbuilt have HA. All of the options of HA. It doesn't need to be exactly equivalent to Windows Server Cluster AG. Because not something is equivalent SQL instance, something is equivalent for AG. But the backend is Server Cluster. Something called Fabric Services actually handling all the load. It's running runtimes. Someone mentioned that. Show a slide. But you can see it basically really low. I know Microsoft presented that like less demanding work. I don't see that. It's really low. It's like 2 gigabytes size of the database and 5 gigabytes just for some pops, something like that. Standard service tier. So everything below it's have like lots of features, including size and everything else. Everything which you think with the size of the instance you want to deploy, the size of the file is up. So you can see there there is a max data size and there is a 3000 TU as well, and latency 10 milliseconds. This is something you can use. Usually, CI/CD deploy stuff like that. It can be. Again, if you're putting some, I won't hire
So there you may have issues. Premium service tier. Premium and the business is exactly the same, a little bit more than that. So premium one is you can go up to 4 terabyte. You can see that latency is 2 milliseconds. We're going to see why is that latency. Standard availability and all those still leveraging the premium model. But latency is different. So this is 1 millisecond. The other one is 5 to 10. That's quite a big difference. We're going to see why. What else should mention? 4,000 use. You may see that always have that limit with the size. So 4 terabytes across all service tier options for a few for Azure SQL database, and you have the same. You choose the vCore as well because vCore purchasing model is for Azure SQL database as well, Elastic Business Pool, and Managed. So you have a general purpose business critical and a hyperscale. Hyperscale is completely different animal. So it's not leveraging the standard, it's not leveraging the premium. It's a little bit close. It's working differently. You'll see how. I'm going to switch to service. I'm not going to talk too much about hyperscale. I'm going to have a session in Infinity in November this year, first and second, and I'm going to deep dive on everything hyperscale because I think this is something Microsoft wants to invest in. And that's just so. You can see general purpose. It can go up to 80 cores and 16 terabytes. Those 16 terabytes was 8 just recently for general purpose for MI. It's not for Azure, it's for MI. Was 8 now added as a few, so it's 16 now. And you may think, like, why am I using only like 16 for a cheaper version and just 4 for expensive one? But there is a reason because one standard one is not reliant on it. At the same time, availability with the that. So you have a little bit less, but again, it's some purpose. I again, I would do that production, so you need to understand how it works. You can become not kind of low, max. It's kind of like it's just general purpose. You have as well for business critical 280 and 4 terabytes. You see the difference. The general purpose is cheaper, but it's sort of less redundant technology to that, but you have more size for your drive for your files. And you have scale. And the biggest gain there, you can see that you can go up to terabytes. So there is a block scale what you can not do, but we cannot stretch that a little later. But so it's a node there which actually explains what the service actually is. It's defined that it's defined, define everything you have in the platform as a service object SQL. So those are defined on the final layer is availability model. So all those deployment models, purchasing models, service, they rely on one of those. So the standard is actually based on separation from compute, stateless, from the layer which is holding the data itself. And the other capability have actually attached SSD to every single physical node. So that's a big difference. The first one on locally attached, which is Jira Dumps, remotely attached nodes. This is something it's just to try to explain. So you can see, I guess like you guys, it's not difficult. Really, once you ask this, you see the first. This is the leg, right? You see the first. Those are your deployments. So you have a. My finger. So you have a Azure SQL Elastic SQL. So there's like those. So you can see that Azure SQL actually can use those purchases on any service here. Because just here is just a big SQL. So if you go to the SQL, you can see everything else except the here. is there. So if you go to the instance pool, you can see just general available the B core model. This side is B core, this side is U. I'm not sure. I think those colors. Not sure how so when you have as well Azure SQL Management instance, and it's just general purpose and business. Now we have three types of redundancy in Azure. First one is local. Second one is zone. That's a still same reach. And you Jira. So we need to understand that. So any of those options you buy, you're gonna have some kind of availability. Because Microsoft is working like you can't get it differently. This is managed service, so they need to patch that. So they can't have option for you to patch that and patch because they have like for a general purpose for a critical 4 9 and 5. That's like the first one is like monthly less minutes. The second one is like less than 5 downtime, which is basically you don't that. Once you deploy, you can choose in which time they want to update your, I don't know, SQL, exit files, whatever needs to be added in the back. If it's planned, it's not you can't choose what's going to happen. But you're going to feel in the best time. So you're not going to see that Fabric Service that is doing that sometimes it's not checking for the drives backups and everything. So you have those here. You can see that business critical and premium is actually leveraging the premium. That's a big can say similar to Windows Server Cluster and full HA, full AG availability. The first one is like failover or SQL, for instance. So you have multiple instances, you have a shared drive. So I think this is clear. So premium business critical, they have some redundancy here, but bear in mind that MI does not support that. So MI application don't have a strong redundancy. They probably don't have any interest because there is no easy way to take that to build a logic to get something. You're gonna have in the region, you're gonna be locally redundant. But if you want, that's kind of you have those two, you have a read scale out, and for hyperscale, you have a read scale. We're gonna scratch it's one of the best. Let's see forward. So those are redundancy options, and I'm gonna go one by one. The standard availability models of all those DTUs and the records and the female availability model one by one. The picture how that actually. So this is the slide. So if anyone of you ever did HA the server cluster and set up all, this is just what you need. So you need to create a business network subnet. You need to create a set to cover those all domain and upgrade domain concepts. Probably you guys familiar with what does that mean? You have that built in PaaS. So that means that once you deploy them, at that point you need to have a set prepared and the VM that otherwise you can't go backward. It's done. So those are the sets. That if you put those machines in different columns, that if Microsoft doing something this rack, you're not going to have the same rack. You need to update the slide, anything in the back network, network switches. You're not going to have the same with update, same call. Like if something out there, it's the same. So you need to prepare all that. So you need to know how to put the DC, how to add those VM to DC. You need to have at least 2 SQL Server VMs. If anybody of you ever deployed a VM but properly SQL usage on Azure, you know that it's not just enough adding the storage of storage. Let's just talk about a little bit about that. So you need to create storage pools. So you need to create storage space. Those storage spaces that you get virtual drives. If you add drives using imaging, you're gonna have the proper interleave size. That's your size of drive, what is reading, stripe size. And you're gonna have the proper number of columns. And you need to set up 64K for rotation, for a volume level. So what happens if you add one additional drive? You build up and you use it for image already available for that because that's actually how it's happening. And you add another drive. You're adding a size, but you don't add the throughput and you don't add the cache option until you change the size. If you have 3 drives and you add the 4th one until you change the size, it's not going to use it properly. So there is a bunch of things you need to worry about. Then you need to create a cluster. You need to add to the cluster to add those feature availability groups, create availability groups, add a database. Then you have a VNS. Then you need to create potential backups to Azure storage. You need DDT to be requested, and that's really pain. All that is already in there. So if you go with the you go with this is critical, you have all this for a general purpose, and every other system which is leveraging the standard model is a bit different, but still have a sort of availability option. First to understand, so when I said any deployment of Azure SQL PaaS, you have the first option. Whatever you put you're going to have a low availability. One way, so that means that region goes down, the data set down, you're down. You'll have a backup redundant, so you can deploy easily and just add those backups. You're ready to go. The second redundant can enable deploying on any to MI. And it can enable that. That means that you stay in the same region, but different data. So you don't have those available. Those kind of things, like they vary. So you need to find that the region having that option. Not every region will data centers. There is a list of a page you can see which ones support that. In this case, you're still not having DR. You are regional redundant. Data center is down. Still have a second one, but you don't have a pure application. Pure redundant. One way. With the failure, without the failure, you just do the geo active application if you want. This is the zone. This is the pure redundancy. So this is the proper DR. So you're gonna have you're gonna read by listener. You're gonna have that. Don't need much. You have a primary SQL, secondary SQL, primary trade. Check the database. You're gonna have all that. It's kind of sorry. I'm talking. So this is the basic standard general purpose field, locally redundant. So this is what I'm saying. You go with the cheapest that you're gonna have. So you can see that you have one control ring which calls gateways. Okay, those gateways actually become load balancer. I missed to say that when you pull your HA, the VS to deploy the load balancer, you access from load balancer. So it's kind of tends to be messy. That's easy part. Maintaining that is hard part. So for this one, you basically it's fully managed. You don't need to think on the back end. What happened? You can see that the VMs, basically those are nodes. You have one primary one, and just your SSD attached is just your 10 DB and MDB database is there. The LDF 8 files. So data files, LDF files, they are on the premium storage. You can see it's fully redundant, but it's a premium storage is there. If failure happens, there is no syncing there because it's still one location. So that's the reason with MI because we are talking about Azure SQL database, only talking about MI. In this case, it's the same. It's the same technology. So this is the reason why with the general purpose, you can go wireless. Like, can I add 3 terabytes? Because it's easier. There is no secret in the nodes. And you have a which is geo-redundant, so it's kind of protected. You have automatic failure based on Azure Service Fabric, which means you have those runtime checking the health of your machine, but you can do this you can do failure and true. That's your decision. And the connectivity redirection, we can see that later when we talk about the read scale out, but that's an option that you get it for logical SQL. Because with the Azure SQL database, there is getting logical SQL, so you can't just speak Azure SQL with logical SQL. That logical SQL, basically your those connectivities there. There is something that usually just kind of like, so we're going to hold and maintain. You're going to use that string. This option is not available very much, but this is zone redundancy. So you have the same thing. The only difference is those available machines node with the spare capacity, they're split in the different regions. Sorry, different data centers. Different data centers. So one downside of that, and you can't go kind of too big with the size of it, is that you need to see those data logs. They're in different split zones. So once the failure happens, let's say that A02, they need to see that data log needs to be there as well. So those kind of sync between. It's good redundancy because you have some kind of safety in the back. You know that something happened in the region, all that is available. And you can see that Azure Previous Storage is non-redundant storage. That's the reason why thinking is happening in the back. One of the reasons I see that Microsoft didn't go more than 2 terabytes for this option. For MI, they might not have this. So that's my guess. Because there is additional in there, so they can think you like, okay, this can cause the issue because 4 terabytes, 16 terabytes is not the same. Can stay there. Yet it's kind of in preview still, so it's gonna add general purpose, gonna add additional cost. It's really small. Yeah, just be aware. I think basically most of the things. Yeah, you can talk about that. I mean, it's in the previous page how the view goes and how it works. That's fantastic. That's brilliant because it's using kind of similar logic which when you deploy the HA, logical entity listener, and the unit which is having the same activity listener, and so on and so on. This way, you don't have to worry about that. It's already enabled those gateways are in the same ring. So for Azure, you can see that application is going to the Azure traffic, and then you see the arrow below. That's actually that redirected connection. So what's that? He's checking where you are. If you're coming from Azure, directly connect you to the node. So every single subsequent after getting data traffic is not there. It's not gonna pass gateway. So that's really cool too. And you don't need to worry about it. It's all in a backend. So Microsoft is taking care of that. This is the premium and business critical reciprocal redundancy. So when you deploy premium CTU purchasing premium service, or we go to the business critical this. So MI or Azure SQL database, you're getting this. So what you have is, what is the difference and why it's important to understand why those limitations with the log throughput, with the size of the, because there is no storage which is holding your LDF files. So it's basically everything is attached as locally attached. It's much faster, stateful traffic, everything is happening on those nodes. So you can imagine maybe 8 months, it was 48 megs per second for Azure SQL and for which was really low. Now it's like, so I'm guessing, and maybe have more and more they're adding, they're investing in that, and that's really good because this is something you can actually do. This is 1 to 2 seconds. If anybody, I'm not talking about a dedicated machine when you have a RAID plus I don't know NVMe drives and you build that yourself and you get 1 to 2 seconds, of course, because you're thinking like running that. And this one with if you structure is getting 1 seconds is almost impossible if you use the drives. That's a subnet latency. Otherwise, all those attached sites, if you use the host cache service, still attached to drives. So that latency is not saying at any point that you're going to have latency on the drive. They're saying that latency from the app to the drive is better because they putting host cache on the drives. They try to move from a cache instead of from a drive. And that have an infrastructure as a service. If you don't choose from here, if you don't choose the proper price in the back, if you go below P30, let's say, and you have a distinct drive, that's going to be good enough. So you have drives, you need to maintain that. You need to actually recognize this cache as your VM. You don't want to put VM with throughput 1000 and put 20 drives and throughput 20,000. So you need to know what is your workload and kind of just from this thing as well. Can't go while you need to set the workload. If your workload, if you have more than 6 megabytes, then yeah, say like I'm gonna cut it down because you need to set maybe it's a few seconds a day or a few minutes a day traffic, but actually like maybe customers not even you need to set workload and then deploy or to choose some other option like a hyperscale. Yeah. So it's the same. Automatic failover in the back. It's fair service in the back, running runtimes and checking all that. As well, you understand that also have those bots or runtimes in the back, it's checking your backups, integrity, and everything else. You can imagine like you have a full backup week, refresh your backup day, every 5-10 minutes. You have a backup. Every single one of those are checked. So imagine like in the world, there's a million. So that's happening in the back. You don't need to. So when you have your AG and your X cluster, you need to worry about it. So there is a huge difference. So for this one, you have option same redundancy. So this is still the same region as I already said. It's a regional PR, but different data sets. If one data set now, the two or whatever is in that region are working. So you can see that every single one of them in a different region. You can see that two of them like in the same. Why is that? Because this is sync commit kind of depending architecture. Because obviously, if you write something, it's not the same drive. Every single one of those files need to be synced because they're separated across different nodes. And all those nodes, it's not like something in the cloud. Those are physical machines. Those are racks with machines, CPU with. There is limitations. So you need to be sure that is how Microsoft is doing that. He wants one replica to be synced to say this is not enough. Additional one is because if something happens, one needs to have all those transactions there committed. So this is how it's working. And the same way and approach to the Azure Manager and the gateway. You can see the gateway is well split in zones, which is really good because if something happens with data centers, you basically have everything which you need in the second. You're not probably even see that something happened. So, and this is not available again. MI for the same reason about the general purpose and the size of the database. Okay, this is a read-only replica. So just DTU model and premium service tier, vCore purchase, and the business give you this. The other one that is the hyperscaler, but that show how hyperscaler is working. It's not leveraging neither. It's a combination of two. So as you can see, when you deploy your database, you can choose do you want to be with a premium and this premium has. So that means when you deploy this, you have your primary with the read write-offs, and you have your readable secondary. You don't need to deploy anything else, just one database. just one logical sequence and one database getting this, getting 4 nodes, physical nodes, and one is C. If you have a geo application, I'm going to show you the demo. You may have 2, but that's something else. So backups again, going to the geo storage and so on. So this is how you directly permission string. So you don't need to use any list at this point. Just for a one single database, you don't need to set up anything. Just deploy database, point to the same SQL server, whatever is the name you put there for a server, and just add application type to it. He's gonna repeat to the right node. So that's the benefits. This is basically you have 4 nodes. If you geo-replicate, you're gonna have 8 nodes. I'm not sure if anybody tries to maintain it. That's like disaster. So yes, this is my favorite. Yeah, I'm not going to stretch too much. As I said, I'm going to talk on this one. It's a big topic. There is a bunch of stuff to try there. The best thing, like you have a database of 5 terabytes. Where are you going to move that? It's really difficult. Those files to do some sharing, like that, but yeah, you have a lot. You want to start adding additional layer there because your shard manager the data is, so it's really something he needs to recognize very much. This is not something. This is data with multiple files. There is no need to recognize. You already know where data is stored. Like best thing is when you can go up to 100 terabytes. How it's working? So you go here, you choose SQL, you choose SQL here. You say you have I mean, the limit is like 80 cores. But don't go, that's cost 1,000. But go less. you go less. And you can, when I'm talking about that, you can, because with this one, you can go with 1 parameter in 4 seconds, and also can be fit over and that's good. So in this case, we have 1 and 2. Imagine bigger. So how does it actually work? What is the benefit? As you can see that the thread file is completely separated. It's having the left zone, Azure P, and the one zone with long-term log storage, point time recording, and so on. We're having the Azure storage there. So it's like multiple layers. And when the logs cached, you see what's happening. It's pushing to the nodes, to the page. So those compute nodes, those are kind of like machines. Use the 5, 4 vCores, stuff like that. You're going to have the if you need to replicas, you're going to have those many compute nodes. Those compute not holding your data. Those are just holding your cache. So it's a caching. You're not even reaching where your data is, because you see that log service once it's committed is just passing that to those cache and know what is there you can be. So you can go up to 5 with the, but best thing is those pages. They're actually exactly the same like those compute nodes, but and you can see that EX, my spelling is bad, but those are resilient extension. That's what the main technology which Microsoft uses. So it's basically like you guys use the buffer, which is like using your CPU drive as buffer pool cache, like extending the memory. So all those nodes with attached SSD doing exactly that. The first one is fast, really fast. We're talking about milliseconds to milliseconds less. The second one is a little bit slower, but you have another layer of caching. It's called page service. So what's happening there? Once you database, because you're not specifying the size of the database, once you define this, you just say you want to have 8 cores and 5 records. When you add the files there, once reach 128 gigs, just split. Every single one of them, it's holding one file. So let's say you have 80 tera database. So to store that, you're going to need like a week or something. But this one doesn't matter because every single one of them is storing at the same time, just to store 20. They're going to extend like from 1K to tera, something like that. I'm just saying what. So you can imagine like storing that matter of seconds, constant store. It's a snapshot right there. So basically, you need that. It's here. So any other technology can do that. Those drives, you can see that's an Azure storage. So it's doing a snapshot backups in the back. Those drives are fast, but you're not even reaching, rarely going to hit that. Because you're going to hit one of those layers there. Those are two caches. So this is something I'm not going to go too deep to it because I'm going to do those sessions, but this is something I think Microsoft is aiming to go because you can't say I have a big database. Currently, if you want to store one bigger 1 terabyte, you have to, or and actually can't store. You need to change service tier, upgrade service from any source. If you have bigger size of the file, I don't like to say shrink because I hate shrinking, but you can split or something like that. And then to that, any of those page files actually page to be attached to the smaller data. So if it's a bigger, once you go there, there is no back. So you can't restore back to the where you work. You can't restore from one to another, like if you guys see whatever job, you can't restore from back. You can upgrade when you're there. There is a way you can go back. I'm just kind of pointing out. But if you're there, stay there first. So it's not about this. It's 100 terabyte size. We're gonna talk about the connectivity of it. I'm not sure what is the time. 1, 2. Okay. We're gonna talk about the connectivity as well. So, what would be the main difference between the MI and SQL database in terms of the we're going to show that this is the MI. It's the biggest difference. There's other things like 16 terabyte size. You don't have that. Have zone redundancy. This one can do database job queries. The other one cannot do job queries. You have jobs and so on. So like we can talk about that day or two. But this is the easiest way to understand. If you need a VNet, you can't go to database. It's not VNet. This is VNet. You can go, basically, but you need to connect like endpoint and that's that. So I'm going to show the measures. So this is so what you can do is the VM and same VNet different subnets. You're going to have everything. Some people like that, configuring those G's and so on, putting tables and opening the port. I hate that. So how this works is actually you have an internal load balancer and external load balancer. So if you need some application which is like a VM, split the VM, you want to have in a different subnet, connect to the internal recognize the DNS, direct you load balancer is redirecting you to the gateway, and based on what you have, let's say critical, and you have a only going to redirect to the proper one, and everything is encrypted and everything is secure. So this is something like from a networking point of view. I don't like all this. It's a back of the thing. I'm not sure if you guys try to deploy the file. When you try to deploy, it takes like 6 hours. Or something. The reason is this virtual cluster. It's actually gesting the virtual cluster to you, the VNet. And that's the reason. When you're going, that's the reason why you want to use one virtual cluster for multiple instances. So you have instances, but you need to do PowerShell. You can't just create that. So just play with that if you want that option. If you go outside and you want to use the Power BI or some other, you want to connect, go into external public endpoint, which is external load balancer, and it's going to the internal firewall, which is checking the traffic from where it's coming, so on, checking those which you may use, and to the management agent actually redirect where you're supposed to. Setting all that yourself, infrastructure is not easy. So I'm not sure if I did that, but just set up all those internal bugs, pull the VMs in list, name, type, and so on and so on. Externally, sometimes if you want to have outside and so on. This is kind of like you have already VNet, you have already everything existed, and it's simply working secure. That was that. This is the Azure SQL. This is the Azure SQL. So this connectivity option is not available on Azure SQL database. It's available on logical SQL server, which you use to store your database. It's a classic holding Azure SQL database because I always what is the point of logical SQL server? Those kind of things like permissions, access, connectivity, and location. Put the location there. Then you attach that. If it's Australia, it's so you have a default. It's a default. What's happening there? You see that redirect find. That's the first interaction with the gateway. Gateway recognizes the Azure location of outside. Outside, you're going to point proxy. You need to set up again networking and so on, which I hate. The other one is that's a redirect that connectivity is from Microsoft, but that depends on the application. I know that some customers having on different endpoints, public ones on outside machines. One is a VM service, which is like Azure. If you have that, it's the proper way. You will always have a redirect connection. If you don't change the default, this is default. If you don't change the default, if you have that change to redirect, it's going to be directly without talking with the gateway. It's going to go directly to the database. The first interaction is just the gateway. Everything else is hello. It's going directly to the. I think we photo. So we said there is a local redundancy and there is a redundancy. They're both in the same region. First one is the same data center. Second one is taking a data center there. But we know that that is not the DR. If region is down, you're down. You have a G redundancy, storage backups, still can restore and look up and work, but you're down. So you can do, you can spin the failover or just activate your application. That's additional cost. But let's say the left side, you see the primary logical server, you spin another server. I'm going to show you an example once we're done with this. You spin another server, and that's going to be the secondary region. Let's say you want to have zone redundancy on both sides, you need to those kind of regions. So if you go to Australia East, Southeast or East, multiple data centers, if you go with that, you're going to have, if you go US, you're going to have one. So that example I'm going to use. Once you deploy that in the same failover group, if you use the business critical preview, you have 8 points. 4 there, 4 there. If it's zone redundant, because you're not paying for business critical preview, just use it. If you're zone redundant, you're going to have 2 nodes in different data centers each. One in Australia and you're going to have write list, read only list. So what's going to happen? Point out your application to read write list. It's not going to read back you if you put an application connection string. You try to connect connection string application. It's not going to read back to secondary. It's going to redirect to primary on your read. If you have read scale out feature name. So you're going to reach your primary still, and you're going to have one is read only, one is read 2 connections. So if something happens, it's going to redirect to secondary. You can change the base period of but you can change that. Or you don't need to worry about that because service, fabric service in the past, because sometimes something is wrong with your this complete node is doing the issue, it's going to fail away. You're not going to even. At the same time, let's say we said that only premium availability model and those business critical and premium DTU, having those options, multiple nodes operated. Everything else is a sort of kind of like SQL for instance, so it's sharing back all the FMD files, and you have just enable read scale out because there is no secondary readable. I'll show you that later. With this, you have secondary readable because you can point to read on this. The only thing you need to understand is that this is async. So there is a delay. The first one you have business critical premium sync commit. This is a. But if you live with that and it's okay, you can use that with some version not allowing it read scale out because you're going to read on this and it's going to be secondary. The rest of it, like just from my previous session, I had it's the diagnostics logs to log analytics you can use and check what's happening there. But it's really cool. It's kind of management back. It's timeouts, so on and so on. But currently, I'm investing in that options. Like you have through the portal, you can see all that without doing the workspace, with anything there to push those logs because you need to enable and push those diagnostics on Azure that on the but it's Azure SQL database that side. Yeah, one thing to be careful with this as well. So this you have to. Then I'm going to do. Once you have that and feel what happens, you need to understand what is the SQL login, what is the database. So one database you can have something called SID, which is random huge with characters and whatever hash. Creating login. If you don't create a login on the same hash, because this is readable database, you can't change it. Read-only database. This is primary. You can change just there. You don't have the same database. Decide this is going to be read-only. Can't change that. So you need to create login secondary primary. You can go search that to the database something like that, and you have a SQL login. Logins in SID. So if that SID is once you fail over, not be able to connect until you don't those SQL logins into use. So if that happens, you definitely not. Yeah, this summary. Cool picture again. So I think it's easier now to understand. At least I hope so, because it's kind of too much information, maybe. But it's look. If you're just talking about this, you're never gonna grasp what's happening. So you need to go and spin, try, play, and see, test yourself. You need to connect. You need to patient and redundancy, redirecting, and so then you're gonna understand the zone redundancy, local redundancy, redundancy. You use that like on the company expenses, and that's fine. I'm joking. I have MCT. I have some kind of credit there. I usually spend that in the first 3 months. Then I'm using C7. They heard that. So yeah. So you need to understand what you can push to Azure SQL, because those 4 options, but those 4 options leveraging actually in the back purchasing model have a DTU and the big and those 2 purchasing models having 6 different service tiers. I'm guessing it's going to be maybe 8 or 9 next time when I'm speaking about this. And you have 2 availability models at the moment, plus that hyperscale. I did see that there is no error from hyperscale. It's kind of like it's completely brand new, 2 years or something. But anyhow, it's a different way how to do it. It's a different technology. But you can understand like those 4 layers. And then on base of that, that's not enough for you to decide, are you going to move your dedicated one workload Azure SQL PaaS, what you need to do, you need to check it with standard code. There is some tools for the DTU. DTU is basically drive IO memory kind of combination, and so they call DTU at moment. And the V code is equal. It's not quite equal with what you have on the dedicated one. You can't compare one to one. So you need to be careful. There is a calculation, something like really good tools which is you install your DBMS, and it's picked up all those readings from a Windows counter. You have physical operates on, pick up all that day and 24 hours and tell you, okay, you are for P6. Let's say I'll give you a graphic and show you like 60% of your time you're P6, 20% you're P8, or something like that. For vCore again, for me, which I'm looking at database size, I'm looking. You need to know what is the point time objective and the RQF recovery time. For example, like if you want to pull like do you need to have female model is not a standard one. You need to have 2 milliseconds latency or need 5 times good enough. So it's lots of things that which kind of help you decide. But there is as well things which are stopping you if you want. You have cross-DB queries. So you need to go high or code, or you're using something, some difficult maybe ETL, something like that, or using the jobs for agents, but that's already available. So you can use the last jobs on Azure SQL. But anyhow, there is a reason like some guys to have a VNet, and you have to use MI. Maybe you want to have a bigger database that you have like 8 terabytes. Like that, you need to go with the Java on MI. So there is a reasons why Sienna cannot do that, but there is a few tools you can use. DMAs, the tools you can assess your current workload. It's basically what you're assessing your features, you're assessing schemas and everything. Don't have schemas, you're gonna fail, but doing that. So there is a DA tool, which is the experimentation system, that experimentation which is actually creating your workload from the primary and puts in a trace file, and you can use deploy those trace files, you spin them, and you try the file show on MI or Azure database you want, and you can use extended trace file. It's simple to set up all that, and you're gonna use SAS on that middle server in between when you're grabbing the trace from one, deploying to the target one, and you're gonna do analysis. You're gonna have basically which query is slower, which query is faster, how many percentage is back and better or worse. Everything will be, and you have a DNS migration assistant. You can use that to kind of like everything. It's basically for dedicated, infrastructure, whatever. It's going to be online migration. To MI. Yeah. To Azure SQL, I don't think so. I'm not sure. I don't know what to say. Yeah. So it's going to be short now. What I'm going to do is I have a few scripts. I deployed P1. I have a primary SQL, secondary SQL. One is Australia East. Yeah, Southeast. One is the US East. So I have a representation, but I have one S0, which is standard DTU model and standard pricing service. And other one is P1. It's from premium DTU, which leveraging the premium availability model, that full HA, sort of speaking. Bear in mind that HA, when I say HA and availability group, that's not the Windows Server clustering. It's completely different. But you're getting the same thing in the end. So I'm going to show you when you run 2 connection strings each with the application you can read only and without, where is it going to out? That's basically something big. I'm going to run this again and hopefully not fail. Oh yeah. So I always build those machines. I use the PowerShell for that. You can actually build everything in the PowerShell, deploy all those machines with the geo application, the zone redundancy, out, scale out, everything you can do there. Just push the button, 5 minutes, all is there. So I deploy P1, I deploy S0. I'm using the same primary and secondary because why not? One is, as I said, it's Australia, one is USA. So the first one is S0. It's a standard. Let's see there. It's a standard. Okay, you guys can see that? Let's try to. Okay. It's better? I can see. So the first one is S0. First one is S0. It's a standard here. And let's imagine, because I create a geo application, but let's imagine I didn't create a sector. So the first one is locally redundant availability primary SQL endpoint. So once you go there and you say, I want to create a database, it's S0, deploy that. What you're gonna get? So you're gonna put the primary server. That's gonna be our connection string. Obviously, there is no anything else. In your gateway, you can create the role of this. Don't need to do anything. And you say is just connect, show me what there's expression upgradability or something. My state database, and it's gonna say it's right. So you're gonna connect again. The application can be only, and still is gonna say read write, and still because for S0 there's no option for scale out. Don't have a read, but it's not gonna cancel or anything like that. Now we're gonna create the geo redundant. Last picture shows you primary, secondary, failure group, and in this group we're gonna check the database. As soon as that is added, it's gonna be a geo replica. So what I'm gonna use read write listen. So when you build that, I can show you later on in the portal how it looks like if it's visible. It's gonna give how you're gonna see a secondary. You're gonna show you this read write listen. You have a 1 hour grace period. This is your read only listener. So you're gonna have 2 endpoints. So I'm gonna point to that. Say it's still primary first. Why? Because as I said, read only listen. Read write listen. It's not gonna redirect your secondary. As long as you have active primary, that side is your, and that's a good thing, actually, because if you have active, you don't want your access layer to be in USA. If your application is in Australia, you want everything to be. Until that's available, it's not going to fail over. It's not going to at any point. And the second one, you can see the read-only listener. And so you have a read-write listener, a read-write listener, read-only listener. If you point out read-only listener, even if you have S0, you can see the name of the server. It's a secondary, and it's a read. So you're going to have, if you geo-replicate S0, which is cheaper, chips, you have 2 cheap databases on 2 different locations. You have, at the same time, you have a secondary. It's going to be a little bit slow. This in Australia, you're to the USA, and it's going to be easy. Can you live that? If you can't, go to premium business. There is a way how. The third one is kind of stupid, but I just put it. It's directly to the secondary server. Obviously, directly to the point is going to be, but if fail happens, there's going to be an issue. So you're going to point still. That's going to be your. This is shaking. So this was for S0 standard one, leveraging the one. Is this critical? Same. This is the this is P1, I think, the cheapest from DTU. Yes, P1, but this premium DTU handle critical. They leverage the same availability model. That's all nodes. So if you do the same thing with this one, and Australia East, and you can see that the first one, it's exactly the same name. You're not pointing to the listener. It's your endpoint. It's your server which holds you point to that when you're getting it right. If you put application 10, you're going to get read only. So that's going to be those 4 nodes. Nodes actually one of those 3 nodes. If you use geo-replicate, you don't need to geo-replicate this. You don't need a DR. You can redundancy have different data centers. I'm repeating myself because I just want you guys to memorize that. And if you don't want that, it's just fine. You can spin that, and you're going to get this. So you have a geo-redundant. So you have a DR. You have 4 nodes. You have 8 nodes across the world. And you point to the reads, write list. What you're going to get, read, write, and read. So application can read one is going to be read on. But look at the server. It's still going to be primary. It's still going to be Australian. It's not going to go if there is necessary to go secondary. It's still going to. You're using group list. You're not pointing to the server at all. You're using the list name is something there. I'm going to show you. You're pointing to that one. Still going to redirect you back to the primary, and you're going to read from it. You're going to have, because it's premium, you're going to have it still. And at the same time, if you want another one, you can point out to the read only and look at the name of the service. But you have additional information to move completely to secondary. So you have 8 nodes, 2 readable, 1 is S. Do you need that? Oh, yeah, just to know. And the third one, again, just pointing to secondary. I don't know why I put it's pointless. So if failure happens, you're going to have read right here, but only that is going to keep the same because you have it. So let's see. Can I? Maybe it's disconnected. So this is the research group I deployed. Can you guys see that? Oh man. All good? So what we have here, database is basically because you replicate something, it needs to recreate the database. If I didn't replicate that, just go with the I would just have one server. So here I have a duplication for a P1. Such a cool name. You see, S0 and S0. One is in Australia. This one is in US. And again, the same one. And you can see 2 logical servers. 2 logical. One is the primary, one is the secondary. So that's what we deployed. We can go without that. We just have a primary, is 1 logical, 1 done. You have 2 nodes. Everything pitchy. To enable zone redundancy, you're going to see that. So let's just go with the zone redundancy. I want to show you guys how it looks like. Oh man. How we get that? I want to make myself life easier, but come on. Oh yeah. So you can see this is a compute storage database. I think I choose the P1 on premium server on the main server. So you can see DTU. It's still the DTU purchasing model, so it's a P1. So it's business critical. It's leveraging availability in the back, the full scale. You have the scale out table, and you have the zone redundant enabled. You can change that at any point. It'll take a little bit of time for a zone redundancy, obviously, to redirect. This is how it looks like from that side. Now I'm going to show you. Oh, okay, not this way.
I'm going to show you something else. So let's go to the resource group and primary SQL. You're going to go to primary SQL because this is your logical SQL server. It's your filler groups, pulling your permissions, redirects, everything else. There. Just a second. Usually those things like backfire. Research group. Can anybody see the groups? Oh yeah. So we have a failure. I said it's a stupid name. So you can see here, what do we have? So we have primary, and the green one is, you can see what the read-write filler policy can be lower than that. You can see your own logic and put in like kind of recognizing something and just fail is the one. And you have read-write listener there. So when I showed on that PowerShell, pointing to this read-write listener, that read-write listener is pushing your primary. One is available, and you have rate scale out the option if you have a build model. Point there. The other one is read. So if you have a, let's say, using the standard availability models here, you can use eventually if you geo-replicate that readable secondary, don't be async. But the point is, to spin that, you already have one way or another. If you have full scale, like one is like a SQL failover instance, one is more like with AG. I think that's cool. No question.
You'll put it on me. Question. With the with read on these tokens, is it intelligent reads that it's by encourage? So if you have reads or something,
If you have application, you can put listen about async. Yeah, it's just something that I can out because nothing else. Yeah, we can use for except the instance. You can use the Azure. Yeah, for testing this, what I'm doing is just putting the query, which is the database and the nothing else. I actually deploying the whole Azure, but you don't need to do it. It's really simple to the instance pool and instance pool. You can try. It's not at least 2 months ago. Right? Anything else? Anybody? Thank you.
Should I stop?
yeah, thank you, Zoran. Thanks for coming. Has any desire to present at one of these? We're keen people. So this is a deep dive. We will love to do. But if you have any story-based, through then happy for otherwise we'll thanks everyone. Stuff. Stop my question. Understanding out, which is the reason. If you do